All right. Yeah, thank you for so many people for joining the live workshop that hosted by Abhi and I. Abhi, why don't you get started?
Great, thank you, Emma. Hey, everybody, welcome to our workshop on designing advanced analytic patterns with no-code GUI. Whichever part of the world you're joining from, I hope you're keeping safe and during these COVID times. And with that being said, let's move on to our introducing our panelist. I am Abhishek Mehta, Abhi, and I'm Director of Sales Engineering at TigerGraph. In my previous life, I've worked with many wonderful companies, including TigerGraph, co-founded the Bismo, another startup company, and have been doing and designing and implementing complex analytical solutions from 15 years for these big Fortune 100 clients. My first love has been natural language processing, so I have done a lot of work over there. But now it's graph databases, and that's why I'm here with you all today. Why don't you go ahead, Emma, and introduce yourself?
Hi, everyone. My name is Emma Liu. I'm a product manager at TigerGraph. I currently work in areas in TigerGraph Cloud, containerization, as well as enterprise infrastructure, monitoring, and management. So prior to TigerGraph, I worked as engineer at Oracle and product manager at MarkLogic. Thank you, Abhi. You can continue.
All right, Emma. Thanks for the introduction. Some housekeeping item, folks. We have very good attendance today. What I would do is, although your phones are muted, you can ask questions at any time using Q&A tab. So either at a time Emma will be talking or I'm talking, so there is somebody available to answer your questions. And as we will go deeper into the exercises, you may have some technical questions too. So feel free to ask them. And if you have any other Zoom issues, please contact the organizer via the chat. Now, let me take you through the introduction of what we're going to do here today, today's outline. So as you know, we are a graph database. If you have read through the exercise which we sent yesterday, and even you haven't, at least the title tells you that we are a graph database. So we compare ourselves with various other kind of databases out there. So we will go through some introductions of what RDBMS is and what kind of value graph provides on top of that. We will also introduce graphs to you. Later on, we will do environment setup on our TigerGraph Cloud. So along with this exercise, you will be also learning how to use TigerGraph Cloud. There is one exercise on RDBMS migration. Your data lies somewhere out in the world on various different other kind of platforms. So we will show you one platform integration of RDBMS and directly pulling data into TigerGraph. Then we will get into the main part of our system, which is Visual Query Builder. This is where our main exercises for today will be. There are 4 exercises. We will be seeing how much we can complete today, and those which we can't, we will give you some kind of home exercise for that. That being said, let's jump into why graph. So first thing, folks, those who are new to graph, these circles are called nodes, like you have tables in RDBMS, right? And the line between them are called edges. This is same like your foreign key relationship with the other tables. Now, there are 2 components to graph always. They are very pretty to look at. A lot of us have seen these circles around and links between them on a visualization side, but behind that is a schema which connects your data, which is about your use case, which is more about your problem, business logic, what you're trying to solve. So our focus today will be on driving this revolution in business analytics and showing you a value that how graph database like TigerGraph is taking business analytics to the next level, and that too without doing any programming. Now, first thing for us to understand, what is the gap between RDBMS, NoSQL, and graph databases? So I'm assuming a lot of you are technical enough, and as you can recognize on the left-hand side, this is the RDBMS schema. In the middle, you have NoSQL schema, and the right-hand side is the graph schema. It's just not these rectangles, squares, and circles. There are some inherent differences how these technologies actually store your data. So on the relational database side, it's wonderful. It's great for transaction processing. It's though rigid schema, but poor performance on deep link analytics. So what do we mean by deep link analytics? Imagine this schema on the left-hand side, and you are in a big data world now, looking for information which says, okay, find me all the customers who are more than 25 years of age, have ordered more than 20 times from us, and their average sale or average order value is more than $100. Now, for such kind of schema, you would realize first such kind of query, you would realize first this is an ad hoc query. So RDBMS may not be prepared to answer such kind of questions. And even if you are dynamically creating these queries, you will run into Cartesian join problem. You will make these left join, right join, upper joins, whichever way you want to do joining, and you will turn millions of rows into billions and put some filter criteria to get to the information you need. And that takes the cost of a big data system storing in RDBMS extremely huge. Though you want to value the RDBMS linkages, right, the interconnectedness of the data what RDBMS brings, but it is extremely difficult to scale such kind of solution on deep link analytics and ad hoc queries on a larger scale. That's why we had a big revolution around NoSQL databases. On the NoSQL side, the difference is apparent. There is a limit to how much you can normalize your data, right? They are not so interlinked, not so interconnected together. So they may give you speed on certain use cases, but their value lies in joining various different kind of data sets together and firing the queries on top of it. So this whole idea of making some kind of joins or traversing some flattened structure really isn't providing that much of value what companies need these days. So that's why we welcome graph databases in the market. You're seeing these circles. It's just not that we have turned the rectangles into the circles here. The inherent difference is the storage of the data. These are more like a pointer system. This is more like a linked list in your memory location. Imagine order connected to the customer and customer connects to all the orders of it. So what you're doing is everything is connected. It's data-centric, connected with one hop to its next neighbor. And what make this bring you value to is that it will give you a thousands of times faster performance over RDBMS because you are not joining the data set, you are hopping in the memory spaces. So I'm going to show you a couple of examples and you will find value to it. As we proceed, I will be displaying a couple of examples to you. I'll be doing a couple of demos also, and you will be creating things by yourself. Now, the next logical question in everybody's mind is what kind of data has to go inside graph databases, right? I mean, that's pretty logical. If you have to restructure all your data going into RDBMS, going into graph databases, it's a big task in itself. So to make your life easier, almost every kind of data can go inside graph database, whether you are pulling it from NoSQL store, whether you're pulling it from RDBMSs, it's your IoT device data, your legacy systems, or you are talking about time series data or log data, everything can be pulled inside graph database with very minimal effort of any data modification. So another aspect is of data engineering. You also want to merge a lot of data sets from different sources. For example, on the left-hand side, what you're seeing here are pretty diverse systems from BI tools to RDBMS to a search engine to Hadoop to raw data files to various kind of data science tools. Now, the question is when you're joining all these data sets together and from a data engineering world, you will face challenges that these data are often in different formats. And hence, joining them itself is a big challenge. And then there are issues related to the security. And of course, there are different attributes in these fields. They're probably named differently. So the graph databases like TigerGraph, which can join data sets on a huge scale, interlink them together, perform on speed, gives you also an advantage of not only solving your one particular use case, but also create your enterprise-wide knowledge graphs, and it takes care of all the securities and all the challenges which you may face in between. So choosing the right graph database is also a big task. And what I would say is that we will come about the advantages of graph database and that too, especially TigerGraph on MPP scale later during our workshop here. Now, let's begin. Let's focus on the schema a bit because this schema is going to come up over and over again in all the exercises what you're going to do. It's a very simple schema. And what you're seeing here is a user that is doing a transaction. On the right-hand side, you're seeing a transaction. And the thing about transaction, it takes two users to do a transaction. And of course, user does a transaction using a device token. Device could be, well, be a mobile, it could be a credit card, and a payment instrument can be a PDA, or it could be, well, be internet or something like a PayPal account. So what you're seeing here is one-to-many relationship with the user and device. A user can use many devices. Devices can be used by many users. There are transactions. It takes two to do the transaction. So we will be building on this schema today. It's very, very basic. And first thing that I will be doing is converting, showing you how such kind of schema gets converted into graph database. So the first challenge, what we have learned working with all our wonderful customers, and top 6 global banks use TigerGraph. World's biggest 6 banks use TigerGraph as their analytics strategy. First thing what we face everywhere when we start is that we don't have in-house experience in converting our existing schemas and existing databases into graph. So that's more or less like a misnomer. You know, that does not require very special skills. Of course, when you go into advanced level of graph database design and you go into performance improvement and graph algorithms, you may require those special skills, which might be much more easier than what happens on the other databases. But as a beginner, it is something like as simple as converting your existing tables into nodes. So this is what we are going to do here. For each of the table here, I'm giving you a node. And all these attributes which are on the tables can directly be passed on to these nodes. So we will create 4 nodes, as you can see. And all these foreign keys in between them will be turned into edges. So user to user device relationship, you have user to does transaction edge, user receives a transaction, user uses a PI, payment instrument. So let's dig into the challenge what people face while doing some ad hoc query analysis or deep link multi-hop analysis inside RDBMS. What is going to be the biggest challenge? Now we know that transaction, it takes 2 to do a transaction. That's no rocket science. I'm repeating it for the 3rd time. But when it comes to deep link multi-hop analytics and exposing the hidden patterns inside your data set, it is not enough to have a flattened structure of just it takes 2 to do a transaction. Let's say if I'm finding a transaction path between Emma and me, that did Emma and Abhi ever transacted, we may have to go into various different accounts, not which belong to us, but also to the people in between and see if we are transferring money between each other. Let's say there is a anti-money laundering scenario. Maybe you are detecting a fraud or a payment fraud or a device fraud. I may have used various different device IDs in between. So when it depends on finding the paths between the nodes, edges, or your entities, you may have to over and over loop between these tables, doing Cartesian joins or self-loop, self-references to find a path between user A to user B. User A does transaction with B, but B does thousands of its own transaction. And those may be with C, D, E. And what about if I'm finding the relation with the Z? So when it comes to deep link multi-hop analytics and exposing these hidden patterns, there are serious challenges in the RDBMS space. And this is exactly what TigerGraph and the graph databases solve. So let's look at a schema design for this. And this is just not a pretty UI. There is a schema behind it. And I will also show you the shortest path algorithm right on the screen over here. Now we know one hop from one particular hop or from a user, we have all his details. We have his account number, phone number, email address, and account also has a credit card, let's say over here. Now, when he sends a payment, which is a transaction, there is a direct path from user to transaction, but as we have already signed out and discussed, the transaction can be done using a device, and it takes two to do a transaction. When these kind of information these kind of linkages take place in the graph database, there is a path to be traversed which is relatively very simple compared to RDBMS. Now let's see what happens over here. We know the user account 2 should have all these setups, right? Because there are details about user 2. And if we know the user 2, we know all the right-hand side details about this user, because this user is again having all the details which user 1 had. So user 2 should be having a phone number, there should be a device, there should be other payments they have been transacted to. And of course, the user 101 is transacting with this particular account. So when your landscape, when your layout is like this of the data, the navigation from user 1 to user 101, those who have studied graph theory in their, as their course materials, will find out that these two linkages are nothing but finding the shortest path algorithm between these two users. So there is no joining of the table. You are just going to one hop neighbor of the next entity and finding the shortest path between these two users. So this is thousands of times faster than RDBMS, finding and exposing these patterns. And this is exactly what we are going to do. And these patterns is something, and this hopping can be turned into the patterns in which Emma will be explaining us today. Now imagine doing the same kind of analysis, finding all the paths and getting to the user and correlation, whether using transaction or phone numbers or devices, doing RDBMS. Either you have to normalize the data set like this, or you just have to keep on making the joining of the tables and run into some serious performance challenges. So that being said, I think I gave you a brief overview on the graph database side. I am going to stop sharing. Emma, will you share your screen so that you can walk us through the environment setup?
Yes. Yeah, I will share my screen, and let's set up the environment. So this is being a live workshop. We're hoping that you will be able to follow along with all the modules that we prepare for you. So the first step, let's set up the environment for this workshop. First of all, I just sent the workshop guide in a chat, so you can download that workshop guide and follow the instructions on that workshop guide. And what we're doing now is register on TigerGraph Cloud. And the URL is tgcloud.io. And after you register, you can start a blank solution at free tier at the following region, either one of the 5 regions. We're trying to avoid the Northern California region because it's a very region for, there are a lot of active users on the Northern California region now. So let's, the instructions is on the training environment and registration. And if you actually have troubles registering for a TigerGraph Cloud account, email support@tigergraph.com. And also you can message the panelists and we can help out. Again, the workshop guide is already sent in the chat, so you can download. I am going to just do a quick demo on how to do the TigerGraph Cloud registration now. I'm going to stop sharing this slide. Let's go to the TigerGraph tgcloud.io. And once you arrive here, you can go to the sign up page. And I'm going to do a quick demonstration on the registration workshop. Okay. You can enter an email address that you would like and enter a password. Okay, and then sign up. So now the system will send a verification email. So you should receive a verification email in this step in the email, and clicking to, I'm doing this on my Gmail account right now, and click on confirm my account. So now I can go to the login page again and just log in with my email and as well as the, okay, password, right? Okay, I think I forgot my password. So let's just reset my password. Yeah, this happens a lot. So let me go to my reset my password in the password. And so I'm actually doing this in the background now. And let's just try this again. All right. So not only I showed you how to register, but also showed you that if you forget your password, you can use the reset password. And now let's just use the registration, finish this registration step. And agree to the term and submit. Voila, you're at the TigerGraph Cloud dashboard. And in order to start the first solution for the module, you can go to My Solutions here and use Create Solution. You can choose the version. There are two versions, but for this workshop, let's use 3.05 because the no-code workshop is in version 3. Let's start a blank V3. This is for module 1. And next, AWS. You can use the free tier, which doesn't cost you money. And I'm going to choose in Northern Virginia region, just to avoid the very busy NorCal region. And next, we'll keep everything here. You can change your name the solution and tag. And again, this is another password you definitely need to remember because this is a password to the TigerGraph solution you started. And if you forget this password, you will have to terminate the solution and restart this solution provisioning. Demo. All right, just put a subdomain you like and description and go into next. And you will see the summary for this. And of course, you can go back to change things if you want. And you can also see that the price per hour for this free tier is $0. But if you choose another tier, it will show up what's the hourly price there. And let me submit. Okay, normally it will take about 3 to 5 minutes for provisioning. So you can just, as you're preparing and follow along with the workshop, the solution should be ready for the module 1 exercise. Let me just go back to the slide. Again, it probably takes 3 to 5 minutes. I'm just going to pause here and let's come back at 9:30 a.m. and we can continue at 9:30 after you finish this step.
And this 9:30 is PST time zone, right?
Yeah. Oh, yes, right. PST.
So please check your spam folder in case password reset didn't work. This is a very common thing what people do. So it should be working.
Yeah, sometimes for some of the email account, it takes 2-3 minutes to get there. If after 5 minutes during the next part of the presentation, it's still not there, please submit a support ticket, support@tigergraph.com, and we will get the cloud backend engineer to help you.
So there is a question on how can I access Northern Virginia. So what I would tell you is, please, once you are in the TigerGraph Cloud, go to My Solutions, pick up the solution as Emma was suggesting. You have to go to Create Solution on the right top, pick up the solution what Emma suggested you to create. And once you pick the solution and you do click on the next, you would see all the regions under AWS, what you're told to access. There are 3 parts to that web page. The first one is select platform. Second one is select an instance type. And the third one is your region where you can see Northern Virginia.
Yes, it's under the instance setting, step 2. And for the pending task, yes, it will change after you provision. It takes about 3 to 5 minutes for the backend server to be up. That's why it will take a while for the instance to be provisioned. It's underneath, it is, if you're using the AWS platform, which is for the free tier, it is provisioning the cloud resources that's required for the TigerGraph software to be running on. So that's why it takes a little bit of time for the solution to be up. So welcome to TigerGraphing, this banner. This is for letting you know if you're using, you can use the free tier, but if you want to use paid tier, you can also go here and, well, actually, this is just introduction, but you can look into the details for the paid tier. And then, of course, you can come to here to input your credit card. So this is basically an informational panel for you. For this workshop, you don't really need to worry about this. Yeah, here actually there's another link to just directly get to add credit card. All right, I think we're at 9:30 a.m. PST time zone. I'm going to just continue. You will still have more time in the later modules to finish this registration process and finish the other exercises. Let me just present again. Let's continue. So I want to just quickly go over the no-code graph analytics introduction and overview. So first of all, for TigerGraph 3.0, which was released at the end of June this year, we have included many features that is super useful for adopting graph analytics in your enterprise. And we have a few of the product focus. The first part is ease of use, which is making TigerGraph very easy for everyone to use. And no-code analytics is actually included in this feature area. And the second part, it is better together, which means we are making it easier to integrate with all the ecosystem connectors. And you can see that in module 1, the no-code relational to TigerGraph, it's part of this better together equation as well. And the third part, of course, we have very good performance with the leading graph database and in terms of performance and also scale for large data set. So we are still improving, enhancing our lead in this area in 3.0. There are a lot of features, but I want to just go over the highlights for this 3.0 no-code features. The first one, as I mentioned, no-code migration from relational database to TigerGraph. It is very user-friendly, and it helps people who are familiar with relational database to move the data and transition the relational schema to a graph schema. So you, within a few clicks through the GraphStudio interface, you're able to get a automatically generated graph schema, as well as loading the data from the relational database into TigerGraph. So it's super intuitive, and it definitely helps you, people who are in the relational world, to speed up the ETL process. And of course, we actually also built in some flexibility, and you can have customized options when you're loading the relational database into TigerGraph. And of course, the graph schema which is generated is a first recommended draft. If you want to optimize a schema, you can still do that in this design schema step and also the mapping data to graph step. So there's a lot of options for you to do. Let's continue to the second part, the no-code graph analytics with Visual Query Builder. So this is a super exciting feature in the sense that users can use the graph analytics in drag and drop way. So if you are familiar with TigerGraph, we have GSQL language, which is a Turing complete query language to query the database. Users still need to learn how to use GSQL to query TigerGraph prior to 3.0. But with this new feature, Visual Query Builder, which you can also find it in the GraphStudio under Build Graph Patterns, you don't really need to learn GSQL to start using TigerGraph. You can just drag and drop using the icons that's from the schema, and you can construct many patterns. And this is a declarative way to find the subgraphs in the entire graph that you imported into TigerGraph. And of course, like, we're hoping that this will help decrease the learning curve to use TigerGraph and the graph analytics in general. And the beautiful thing about this feature is we actually also automatically generated GSQL behind this pattern. So if you're trying to learn GSQL, there is a example GSQL already generated behind these patterns, and you can also learn about how some of the GSQL features. Just high level in terms of the no-code data workflow. So these two tools actually has a complete path from data into TigerGraph and query outside of TigerGraph. So this is not the only path that you can take. As you can see from the left-hand side, if you have a relational data store, you can use the RDBMS to graph and change the relational schema and data into the auto-populated graph schema and also data mapping. And then you can go over to the no-code Visual Query Builder and use drag and drop to generate the graph patterns. And then, of course, there's the auto-generated GSQL queries. And with these two, you can get to the RESTful endpoint and get to the other analytics, your application and other business intelligence and dashboard all those things that you guys are using on top of TigerGraph. And of course, this is not the only path. As I mentioned, you can import from many other data sources and just use the regular ETL data loader and looking at your own graph schema and data mapping. And Visual Query Builder is still applicable to all of the other data import paths. So that's why there's this green path is the no-code path. And if you go through the other path, the regular ETL data loader, you can still use Visual Query Builder as well. All right, who are we designing for? These no-code tools, we're really hoping that we're going to reach a lot more audience that are excited about graph and data architects who are transitioning from relational to graph. And you can have a first draft auto-generated graph schema. And of course, business analysts who just want to explore common graph analytics and patterns and don't really want to learn GSQL. And then also data scientists, this is a very common pattern that we're seeing that data scientists are wanting to examine the graph features for machine learning models. And it's actually pretty straightforward to use these no-code Visual Query Builder to get those patterns out. And again, I mentioned that GSQL query is also automatically generated. So developers who are actually using, who are trying to learn more in depth and advanced techniques, you can also use this no code to get started. I'm going to quickly talk about the workshop format. So we have 5 modules. The first module is RDBMS migration to TigerGraph, will be led by RB. And then we have module 2 to 5, which is the Visual Query Builder, the graph patterns that we're going to build. And we actually designed that module 4 and 5 are optional because it's towards the end of the workshop. So let's see whether we have time to get to 4 and 5. And each of the module, it's we will go over the overview and then go over some demo and also go over the instructions. We'll allow some time for finishing the exercise in the module, and then we'll start the next module. And each of the module is actually independent. So if you decide that you don't want to finish the previous module and start the next one, that is okay. You don't need to finish the first module in order to proceed to the next. And also there are optional exercises included in some of these modules if you have more time. We're considering that each individual has different pace in terms of finishing the module. And of course, all of these exercises are still available for you to try after this workshop. So don't worry if you have to, stop at certain steps, and you can pick up later. Some more resources. I think the workshop guide is already in the chat. The conference portal is not relevant here. And for documentation, we have, I think I also included in the workshop guide with more documentation if you want to just refer to the official documentation for using some of these tools. And TG Cloud, I hope by this point you've already logged on to tgcloud.io and registered for a profile and started a blank solution. And of course, there's some tutorial videos that can help you to understand the different no-code tools as well as the TG Cloud Get Started video. All right, with that, I'm going to hand back to Abi for module 1.
Thank you, Emma. All right, so let me start sharing my screen. All right, folks, so a lot of talking, a bit of action. So let's get started with our first module here. So what we're going to do in this module is that we are going to connect to a MySQL server, and this server credential will be provided to you. This is also in your Excel sheet, and we will import the data from GraphStudio. So you will also be introduced with the concept of GraphStudio. You can do this as you are seeing me doing it, or you can do it later on your exercises and just see how I perform this action. Now, going back to our RDBMS migration, RDBMS schema, as I said, you will be seeing this schema over and over again. This is exactly the schema we are going to pull down from an AWS instance where MySQL is running. And here are the credentials on the right-hand side. So that being said, let's get into TigerGraph Cloud. If you go back to your solutions, and you should have a blank solution running for yourself, what I'm going to do is I already have a lot of instances. So I am hitting the GraphStudio. So what I have done here is under this applications, you have two applications. You click on GraphStudio, and that would bring up this GraphStudio port, which runs on okay, that's irrelevant where it runs, which port. Now, this is our GraphStudio, folks. On the left-hand side, you can design your schema, map your data, load it, explore it. We are going to go through some of the parts today. And on the middle, you can see some action items. We want to migrate relational database, existing from existing solution, import, export, and all those details. So I'm going to click on this migrate from relational databases, and I'm selecting MySQL. There are two options out there. There was a question earlier that can migration take place outside of GraphStudio? Absolutely. You don't need visualization. We have a very well-developed connector framework from your Hadoops and Sparks. But today, our subject is no-code UI, so I'm going to import it from MySQL. More and more database supports are coming as this product is getting released almost every month with a new patch and update. So as I clicked on the MySQL and I clicked on the next, asked with the server details. Let's go back, pick up this server. It's the port number 3306. Database name is fraud demo. I have a demo user, and the password of this demo is also given to you in the exercise, and both in this, so I'm sorry. And both in these presentation, both will be shared with you. So here we go. I have put in all the details, click on the next. And as you can see, I connected to the database, and my database has device token table, and these are the attributes on top of it, payment instrument, attributes, transaction, user, user device. You can change and decide what you want to bring in, but initially for your testing purposes, I would suggest you do it, leave it by default. Just leave it the way it is right now. So I'm bringing all of these details in, and here is the name of my graph database. So what you're seeing here is a graph database name. You can change the name whatever you want it to be. You can create index for all the attributes that are indexed in your graph database, and you can limit the records, what you want to bring in. So I have left everything default. I'm clicking on migration, and the first thing is it is creating the graph schema. The graph schema will be created inside GraphStudio. You would see it in a few seconds. And also some data will be imported, whatever the limit you have sent. So this is going over the network, pulling the data into our system right now. Let's give it a minute or so. And now it's dumping the data. So now, as we're creating your default schema, you had a first option of choosing the attributes or tables or not choosing it. But the second thing would be that you want to design schema in a certain way. Graph provides you an advantage is that you don't have to create the tables in between to take care of one-to-many, many-to-one relationships. So what our system did is that first thing, it is asking you to verify the schema. That is this the schema you are good with? So I clicked on it. Basically, it took me by default to design schema. And as you can see of the RDBMS, there is an extra node here, purple one, user to device. This is not something we will need for designing a graph database, right? You see this, there was a one-to-many relationship being captured over here in user to device table. So you can keep it. Initially, if you just want to test it, feel free to keep it. What I'm going to do is, along with this particular node, I'm also going to show you how the deletion, insertion, addition of new nodes and edges work. So I don't need it. I don't like it. I'm removing it. So I clicked on the button on the top navigation. I removed it. And I'm creating a new edge directly between user and device. This is going to capture my one-to-many, many-to-one relationship both ways. I'm calling it device user. Or user device, whichever way. So there are some best practices which are available on the website. What should be a node? What should be an edge? That's an advanced level thing. You can look at it later. You can check out docs.tigergraph.com. But right now, I have just removed the node, creating an extra edge. Here's the yellow warning on the top telling you this isn't saved. So go ahead and save it. So I am publishing the schema with this upload button on the top navigation bar, telling me what you're doing, confirm. So now I have told our system, my migration, whatever I got in, is the right schema in here. So the next step, as the graph schema is being created, next step should be to verify the data which is going to be loaded, because I have changed the schema, right? The default loading will not work, or it may be missing some links. So it's asking me to verify the mapping next. When I click on the verify mapping, you see we go into map data to graph. Over here, you have many options. You can bring in data from S3, but right now that's not a subject of discussion. I'm going to import these CSV files. And as you can see, there is an extra file in the system, MySQL fraud demo user to device relationship, because I removed that particular node. So one way of data mapping is, again, doing it from map data to graph. I'm going to click on this node, this link up there, the cross link here. Map data, verify the vertex and edge. I'm clicking on the CSV file. I'm clicking right in the middle of our edge. And here I am telling the system that my user ID, this is how I'm connecting, my user ID in my CSV file on the left-hand side is actually the source vertex ID here. And my device ID is this particular device ID. And this is going to take care of my one-to-many, many-to-one mappings. Now, once I have made these changes, so there are a lot of capabilities over here, right? I mean, we have a lot of functions in build. These are ETL functions, ETL capabilities, concatenation, deletion. You can bring in these methods. You can massage the data a bit. Also, there is a scripting way of doing what I'm doing right now. That's very powerful also. There are temporary tables which will come in between. Sometimes you have to merge many entries from CSV or other sources into one. But this is a simple use case. We have all those capabilities. Eventually, you will get used to it. And once you're used to it, you can explore more. So I'm going to publish my mapping. It was done very quickly. The next step, which is left, is load the data into the system. As you come into the load page on the left, the system is ready to load data. Our system can load these kind of files in millions per second, right? I mean, this is extremely fast. We have a parallel loading in place. If you have a multi-machine cluster, you can load data parallelly. So our benchmarks have been like 5 to 50 times faster than our competition, and some of the competition on the loading side itself. As you can see, all the data went in, transactions still coming in. We loaded 2.3 million vertices, 1.9 million edges in a matter of no time. And if you saw a delay, that was because the warm-up process took time. Now, great. So your data is in now. So what can we do next? Let's look at the system, explore the data. Over here, what you're seeing is an exploration window. There are two ways of exploration. You can start with all the top 5 or 10 or 20 picks over here, which are our entities, or you can pick up a particular vertex. So I'm going to just pick up top 5 users, and I'm going to double click on a user. And you can see this user has many transactions. One thing you remember, folks, we talked about a transaction should have another user, right? So this is the data linkages. This is the data link which got created by default. This user logically should be doing many transactions. Here we go. And here we have a payment instrument. This payment instrument should have been used by many users. No, it wasn't. So let's look at the other transaction. Each of the other transactions should also have a user, and this user should have its own transaction. So folks, this is not about beautiful visualization showing you green, red, yellow, pink dots. The idea is the data actually is stored exactly in this way. Visualization is a byproduct. The schema you created initially stores the data like this, and the advantage of this kind of system is from this orange point here, which is a payment instrument, to a transaction over here, there is a path which you can navigate, which does not come out of RDBMS or tables or joins. It is a direct 1-hop, 2-hop, 3-hop, 4-hop link between this data set. Now, somebody looking for exposing a hidden pattern inside the data set and asking that what is the correlation between this transaction and this transaction. Let's say you are a fraud analytics guy, you're finding shortest path on a traffic route, or you are doing a recommendation system, whatever way you want to do this, use this system, or whatever use case you have, finding this automatic hidden pattern inside your data set is a very powerful capabilities which Graph database provides you. I can say, show me one shortest path. So this is out of the box between these two transactions, which I selected. We already have few million entries on a very mediocre site system. Find that path. And here we go. The system says, this is the path between these two guys, 3 hop, 4 hop, whatever those hops are. You can find many different paths, show all shortest path. This can take a little bit of time, but okay, there is no more path. These are the only paths between these two users. So this is the value of storing the graph data in the graph database format. It can give you interlinkages of the data set. You can navigate from one point to another very quickly, exposing these hidden patterns. No challenge on your, no challenge of joining the data set and inner joins and outer joins. So this is the biggest advantage of graph databases that you can see now visually. There was a question earlier on the shortest path. So this is how you do shortest path. You can also do all these things using RESTful APIs, JDBC drivers. We have it. And there was another question which was asking that, can I give access to the user? So left-hand side, as you can see, you can create multiple graphs in a single instance. You can go ahead and have 10 instances of graphs over here. You can share the vertices. You can share the edges. You can create new graph use cases, new graphs which are totally mutually exclusive, inclusive, overlapped. So all that possibility can come and you can create a new graph and you can see it later on. Another question which was asked by somebody is that, can I give access rights to my user? Absolutely, you can. So if you click on the admin on the right top side, under the user management, you can go in, you can create new users, and you can give them access rights. Somebody is a global designer, administrator, query writers, and query readers. With that being said, let me go back and see how we're doing on the time. You can do this exercise, folks. This is very straightforward. You will get details in my presentation too. But other than that, this is the module. Emma, do you think we have time to let them do it, or how do you want to? How are we doing on the time for your exercise?
Let's give 5 minutes to finish, because I do see that there are comments in the chat that some of the attendees cannot follow along. Yeah, can you go back to that slide 28 and then just provide a comeback time?
All right, folks. So let's come back in 5 minutes. And if you have challenges,
which is at 9:59.
Yeah, let me say 1 p.m. Eastern, if you don't mind changing it to Eastern now, because Emma and me are in different time zones, 3 hours apart. So folks, you got 6 minutes, please, 5 minutes now. Please try it, ask your questions, and then we will move to the next module. And here are the details if you need to connect to the server. You don't have to drop the schema. You don't have to drop the nodes. You don't have to do remapping the way I was doing. That was just an exercise to show you the capabilities. You can just go in all the way default till the loading of the data without dropping anything. Let me take a few questions if I can. So there is a question regarding Cambridge Intelligence. Yes, there are a few tools out there, Keyline, Cambridge Intelligence, Graph History. There are various different Python libraries. So we provide you capabilities on RESTful APIs. We have JDBC drivers. We have TigerGraph, which can connect with your data science tools. I have few of them running on my screen right now. So integrating with any third-party tools for visualization or just for your workflow purposes shouldn't be a challenge. on my screen, you can see on the left-hand side, if I'm not disturbing your exercise, is how somebody can call TigerGraph with RESTful APIs. Just give the right port number, which is 9000 by default, your IP address, so your instance address, which I was working on right now. Click on echo, and here's the handshake. Error false, hello G-SQL. There are various different capabilities. You can file queries, delete edges, you can see system statistics. And again, there was I saw two questions on Cambridge Intelligence. Again, we are agnostic, whichever way you want to use it. But those kind of tools, Keylines, Cambridge Intelligence, are visualization tools. TigerGraph is more a graph structure. The story, it's a graph database. It's ACID compliant. When you work with TigerGraph, you're working with the deep link multi-hop analytics software which store data in graph structures, and that is why our performance can be, thousands of times faster than just visual analytics. And you can go 100 gigs, terabytes, petabytes of data stored on TigerGraph. Well, let me take back the petabytes, but yeah, we have terabytes and terabytes in production. Petabyte is something which we are testing on right now. And we are expecting in 3 months, we will give you some kind of benchmarking on petabyte data store.
Abhi,
so how do you encrypt? Yeah.
Oh, Abhi, I think there's a chat of how did you get to the RDBMS string? Can you show where the no code is on the GraphStudio homepage? In your solution?
Yes, absolutely. So if you go to your solution, which is the home of your solution, right, which looks like this, you click on the left top side, which says GraphStudio. And once you click on the GraphStudio, you would see migrate from relational databases. Click on it, and you would see MySQL popping up and Postgres popping up for you. Data files are, where is the data file located? Data files are in a specific directory inside TigerGraph installation. Since it's a cloud instance, you probably don't have to worry about it much. But if you need copy of it, you can get into your cloud instance and get it from a specific directory. If you look at our documentation, it will tell you what directory the data files are. It's some /data inside TigerGraph. Oh, thanks, Emma. I didn't realize you were answering that. There's a question on encryption. Yes, it's a database. So data is by default encrypted. And then you can also use hardware level encryption. You can also use operating system level encryptions along with TigerGraph. So let me stop sharing my screen. And so I will be coming back in probably 30 minutes or 35 minutes back talking about our capabilities. In the meantime, Emma has helped me to take over some of the tasks which I should have done. Thank you, Emma. Please walk everybody through your exercises on the pattern generation.
All right. Yeah. Thank you, Abhi. I think there's some additional questions in Q&A, and maybe you can address that. Yeah, let me just get started on the module 2, which is the exciting part of the Visual Query Builder. Yay. So let's take a look at, we kind of went over the Visual Query Builder overview before. Again, this is, you don't need to learn G-SQL to use this feature. So it's very, very much designed for business analysts and data scientists and developers who are starting to use TigerGraph. And it's drag and drop. And what is important is when you have a question in your mind, for example, here, I want to find all the people who are friends of me and my manager in company X and Y. And you can think about this query and break it down into different entities in your graph schema. So again, we're trying to designing the TigerGraph and Graph Analytics for everyone to access and use. We're very excited that we're seeing a lot of great comments and feedback using the no-code tools. All right, how to build the graph patterns in simple steps, right? From high level, we have this 5-step. The first step, analyze your inquiry. Again, I mentioned one inquiry before in that presentation 2 slides ago. When you have an inquiry and think about your inquiry, and then step 2, identify and break down the entities and relationships in your inquiry. And after that, you find the entities and relationships. They have corresponding vertex and edges in your graph schema. And then you can, step 3, pick and merge some of the vertices and edges that you're trying to find out the answer. So pick and merge, that's a very important step. And with that, you can construct a graph pattern. And step 4, of course, your pattern, if it's not a simple pattern, you probably want some conditions on the patterns, on the vertices and edges. And you can, on step 4, you can add the filters, aggregations, orders, and limits. And of course, you can also use parameters. And also we introduced this concept of widgets, which are looking at the unions and intersect and of the results that from the other vertex. So this is another tool that you can explore to use. In step 5, you can output your results. We have a new concept called output flow, and that's a very easy way for you to make one of the vertex or edges into the results that you want to show. So you can use this tool to also verify the results that you're doing, because you can basically toggle on and off, so that some of the vertex and edges are showing up in the results or are not. Again, we have an overview video here, tigergraph.com/no-code. It's also in your workshop guide. With all these, you can go over the videos, and let's get to the next part. For this exercise, we're going to start with the easy graph pattern, and you'll get a chance to use the Graph Visual Query Builder in the GraphStudio. So this easy pattern is finding the referral group for a given user. As you can see, so these are in the pattern that we're going to show, there is a user and also another user, and there's an edge of user referred to user. So in this pattern, you're basically trying to find for a given user ID 24142, who are the people referring this user. And this user also has a trust score as an attribute. And we want to order the trust score, order the user according to the trust score. So I will be showing this demo in the live setup. So you will see, what's the overall schema. And we basically chose a subgraph pattern in this graph feature that we're going to show. Again, this is finding people who referred user 24142 and order this group of people according to their trust score in descending order. So the concept that we're trying to teach you in this module is, first of all, there are 2 approaches to construct patterns. One is there is buttons to add vertex and edge patterns. You can add it directly. And second, there's a convenient tool called pick and also merge. So you can actually use these 2 tools to quickly pick the patterns and edges and vertices from the graph schema. And second, we're going to add filters. And the third, we're going to use the output glow to show the results. I'm going to mention about the environment setup. So this schema is very, very similar to the one that in module 1 and that you imported from the relational database. But to make it easier for you, we also have a starter kit that's already ready in tgcloud.io. So basically, what you need to do here is first, you can terminate the previous free tier solution in TigerGraphCloud.io. And the termination process usually takes about 2 to 3 minutes. And then you can also, the step 2 is create a new solution using the starter kit fraud and money laundering detection. This step, again, it takes about 3 to 5 minutes for the new solution to start. The reason that we're terminating and creating is because you're using a free tier without credit card. If you have entered a valid credit card, you can actually skip the step and create the new solution in step 2 using a non-free tier solution in any of these regions. So it's up to you to whether to go through the termination and then create a new solution again, or use a pay tier solution. If you have a new account, there's actually $25 credits in your account. It should be able to last you through this workshop to get through the pay tier solution, fraud and money laundering detection. All right, let's just get to the demo part here. I am going to my TigerGraph Cloud portal, and I already have one of the solution ready. I'm actually using a pay tier. And let's go to the GraphStudio of this. Actually, I had a lot of questions regarding the password. So there are 2 passwords and user that you should be concerned about. First is the TigerGraph Cloud portal, right? So this is the account that you just registered using your email address. And then the password is from tgcloud.io, and you can reset that password to accessing this portal. And then there's another account, which is the GraphStudio solution user password. So what is here is during the provisioning step, there were actually password that you are given to the database. So you need to remember that password, and you cannot reset for the existing one. But what you can do if you don't remember is terminate the current solution and start a new one and remember that password. So again, let me just log out. Hopefully I remember my password. Normally when you start to go from here to GraphStudio, you'll be prompted here to this screen to ask for the user password, and keep user name at TigerGraph, and password is the one that you used when you provision. Okay, I remembered my password this time. All right, let's just continue the flow of what I actually want to go over, which is the visual query pattern in module 2. Let's go to the anti-fraud. This is the starter kit that you started. And if you look at the schema here, all right, the schema here includes the user, the payment instrument, transaction, device token, and user referral user, and also the received transaction. These are the edges, user to device, user to payment. I think in the module 1, this is pretty much the same graph schema. So we're really looking at, this use case as, let's say, a credit card referral program that maybe some of the users are taking advantage of those bonuses that's getting through this referral program. This is the use case background, right, context. So the received transaction is, let's say, the bonus that you get from those referral program. And user can refer user, and then user are going to use one kind of payment instrument to receive these transactions. And then there's also device token related to the payment instrument, right? So this is the general context of this use case. Let's map data to graph. So this one is already included once you start the starter kit, the anti-fraud starter kit. And for load data, so this is actually a step that you need to go through when you start a new starter kit. You need to click on here, start resuming loading. I already loaded the data here. Normally, after you click on this, it would take a few minutes for the data to be loaded. And you can see that now the data is already finished. So I can proceed to the next step. This is explore graph. And if you just pick random 5, these are just multiple ways that you can explore the graph data and even expand on it. Yeah. So this is actually a quick, if you don't have a specialized graph visualization tool such as Graph History or the other graph keyline that Abhi mentioned, this is a simple graph exploration tool that you can use. And now this is the new feature, build graph patterns, right? And this is the one that in module 2 you will be working with. You can see here we have a order, trust score, descending. We have this user, we have this user, and we're looking at ID of 24142. And now you can see that user refer user, and these are all in orange glow. That is basically what means it's in results or not. So you can see that I can toggle on and off. Let's just save this again. And let me run this pattern. All right. So we can see that the results are here. There's a subgraph that satisfied that pattern, right? This is 24142. And we found 4 people that are referring, the 24142 user. So you can see that the trust score is actually all 0 in this case, meaning that it's not a very trustworthy group of people that are referring the 24142 user. Okay, so now what I'm going to do is in your workshop guide, there's step-by-step instruction on how to do this. And I think the workshop guide actually describe the step to just use the adding vertex and edges directly. What I'm going to show here is another approach to construct this pattern. Let's just do this. Module 2 demo. This is the way to create a new graph pattern. Let's go to the graph schema, which is already here. So you can see you can use this, leverage this to really pick, the vertex and edges that you like. What I'm going to demonstrate here is using the pick tool. I'm going to pick on this edge so that now we have the edge picked and also the vertices that are in both sides of this edge, right? So when you use the pick tool, usually you go to the edge, and then after you choose that, the vertices are also, dragged and appear in the work panel. And now let's work on the conditions on the vertex. First of all, we want to specify the user is 24142. Let's see. What you can do here is going to the basic, once you click on user, this panel on the right-hand side shows up. And you can see that we're at the user vertex. And now what we can do is to add plus here to add the vertex ID, 24142. And click on update. Now we have a filter on the ID. So definitely the 24142 will show up in the subgraph. And next part is when you're looking at the user here, we are going to use the order function. So once you click on the user vertex on the left, you can go to its work panel on the right and go to order here and plus. There are many ways to order it. And now what we're doing is using one of the attributes which is we have a trust score for the user. So this trust score is an attribute for this user vertex. And we want to have a descending order. Okay, we are good on this and done and update. So now we have this pattern. It's similar to the one that I showed in the demo. And then what we want to do in the next step is using in result. And this is basically once you click and making it into orange glow, when we run the query, this will show up. All right, I'm planning to just show, make everything into this result. So everything is in orange glow now. I'm going to save the graph pattern and let's run the pattern. Okay, again, we get to this subgraph that satisfies the graph pattern that we just defined, right? So 24142, it only has 4 people who are referral. And since they are all trust score 0, so they showed up in a descending order in this way. And you can actually see there's a JSON results that you can already included in this pattern. And there's also problem. Okay, no problem has been found in the graph pattern. So this is a useful panel that you can take a look. All right, let's collapse this. And yeah, this is the first module exercise for Visual Query Builder. And again, let's take a look at the, this is the workshop guide that you should have received in the chat or in your email. And hopefully you already somewhat finished module 1. And let's go to module 2. This is the one that you will be building. And again, just remind you, if you want to keep using a free tier solution, follow these steps to terminate and restart this starter kit. And then once it's ready and goes into the build graph pattern, and this is another way to construct a pattern. Just click on plus button for the vertex and plus button for the new edges, right? Yeah. And in the end, save the order and save again, making it into orange glow and play. And the optional exercise is if you have more time, you can explore the toolbar and play with other options. Okay, hopefully you find this module 2, and let's just go back to the presentation. We will give you actually, let's say 12 minutes on this because we are trying to finish module 3 as well. Let's come back at 10:31 a.m. This is PST. So this would be 1:31 p.m. ET. Okay. And I'm going to paste the workshop guide link again, just in case people are not cannot find it.
So I think we have a lot of people asking about, will this session be recorded? Will you get this workshop guide? Will you get this presentation? Absolutely. You will be getting a follow-up email where there will be a recording of this session. There will also be links to the workshop and most probably to this presentation, what we are showing to. The workshop actually has all these details. So we will be sharing all those information with you. And in case you don't find it, feel free to reach out to me at abhi, A-B-H-I, @tigergraph.com. So all those people who are new to TigerGraph, our solution runs on any kind of cloud instance. You know, your AWS, GCP, and also what you're working on is TG Cloud, our database as service. Along with this, our Enterprise Edition can well run on your in-house servers, bare metal servers. So this solution works for you end to end, whichever way you want to run it on your system. Financial institutions run in-house. A lot of others are using TigerGraph Cloud. So whatever is your poison, we can support it. This is a very good question on what type of AI models are integrated with TigerGraph. Now, you want to look at this question from two different angles. One are that your external models, you're using some third-party machine learning capability, whether you're running it in Jupyter Notebook or Python or whichever way, or NLP toolkits. Now, that kind of integration in TigerGraph is though in scope, but at times out of scope for TigerGraph. You know, we would recommend you use TigerGraph as a third, as a separate module. You do the calculation, you do the link formation, you do the feature extraction inside TigerGraph, and bring the data inside your machine learning module. But the thing to remember here is that when you structure your data in graph format, the graph format enables you lots of machine learning AI algorithms which you cannot do it on your data frame kind of structures. For example, page ranking. Page rank algorithms are meant to run easily on graph structures. The performance can be different by 10 times. You can do page ranking on other things too. I'm not saying that you can't. But when you have data in graph structures, you can run page rankings in parallel. Similarly, community detection algorithms betweenness centralities. So graph databases come with their own set of algorithms, which are very efficient to run on graphs itself. And TigerGraph has advantage as an MPP scale graph, which can parallelly store your data, sharded data, and also process it parallelly, and so does it do with your graph algorithms too. So that is a very interesting conversation. You may find a lot of details on our website regarding, graph algorithm. There are tutorials out there on our tigergraph.com website. There is a very good community website which covers all those details. Next week, if I'm not wrong, which I think I'm 90% sure, there is another session being taken up by TigerGraph employees who will cover AI solution building with graph algorithms. So please join that too. It'll be very useful for you if you're interested in graphs and ML. That's a good question. How do you run analytics inside TigerGraph? I mean, first part of the analytics is what is that you're analyzing? One of the questions we are showing is deep link multi-hop analytics. So when I'm finding connection between one transaction and another, passing through any in-between possibilities, 5, 6, 7, 8 hop down, I'm exposing the hidden pattern inside dataset. That's a kind of analytics. Another kind of analytics would very well be where you are doing some business intelligence. You would require calculations, aggregation, summation, count, min, max, running some kind of data science operation on your data set. And that can be done very well on each node in TigerGraph parallelly. As you fire a query, it gets divided into smaller loads, which can be run parallelly on different boxes and also on multiple cores on the same machine, which can do their independent operations of analytics, whether it's going to the depth, whether it is aggregation, summation, join the data sets together, and give you back with the result, come back with the results.
Thank you, Andre, for the feedback on Visual Query Builder. Yes, we will take into consideration on improving usability.
Well, Raj, that's a great question. In fact, I have a whole set of slides by the end that goes over the differences between TigerGraph and other competing graph technologies. We call ourselves as a third generation graph database. Let me see if I can get to that. Otherwise, you can find it on our website, or I can assure you, if you go to our website, you'll see many videos, many blogs. There is something called a buyer's guide on our website, which explains the differences. But in a nutshell, if I don't get to your question by the end, it's the scale. We are a distributed graph. There are none to any distributed graph in the market which are native, run on efficient C++ engines like us, which give you capability of multi-hop analytics at much more lower total cost of ownership and hit the performance like ours. But that being claims, I will recommend you try it out yourself and reach out to us if more details are needed. Yeah, I think Emma, I can probably show that to you. It's just a one click how to do that. Eric Wong has a question, Emma, how to convert output build graph pattern setup into GSQL code.
Okay, I'm going to stop share. Or actually, I can share. I can show that too. Sorry, I didn't see what exact questions were. Okay, let me just share this again. Okay, let's go here as this is the GSQL query that, sorry, the pattern that we just made. And if you want the GSQL query, you can click on here, save as a GSQL query. Once you click on that, you will be able to see the automatically generated GSQL query. And once you do save here, you can actually find this GSQL query here. module 2 demo. This is basically the same query that we just from the graph pattern. And of course, I can also install the query and run. Let's just run the query in interpret mode. This is another new feature in 3.0 that you can actually choose to run the query in interpret mode. Let's just do it again. You can see that from this right query panel, from the GSQL query that generated, you're getting the same results, right? 24142, and all the users that actually referred to 4142. Okay, I think it's getting to the time. It's already 10:32 in my time zone. And let's continue for module 3. So in module 3, we're getting into a slightly more complicated query pattern that we're trying to use more aggregation and order and limit and alias. So these are the you already saw probably in the work panel on the right-hand side. There's these filter, aggregation, order limits. This is what we're trying to get to in module 3. And the graph pattern we're looking at is, I call it a high transaction amount for low trust score. So why is that? Let's look at this pattern here. And basically what we're putting down here is, first, there's a user vertex. And then there's the payment instrument, which is connected with the user. And then there's the transaction that's connected through the user received transaction. So what we're looking at here is finding the user with trust score less than 0.15. Of course, this number is something that you can tune. And then it's also connected with payment instrument with trust score of less than 0.1. And then these, we are thinking that this is a risky profile that's with low trust score, both in the user side and also the payment instrument side. Then we're looking at, okay, this user actually is receive a lot of transaction, and we're trying to sum up all the transaction amount and looking at who are the top 10 user that receive the most transactions, right? The transaction amount. So in the user part, we actually sum up the amount in all the transactions that one user receives. And then we make it into alias total amount to refer to this aggregation sum. And then we are using the order total amount into descending order. We're trying to find the top 10 total amount associated with a particular user. So as you can imagine, this is, low trust score user, low trust score payment, but we're trying to find very high transaction amount. So it's very likely that these people that are fraudulent users, and we should take, investigate more into their behavior. Okay, let's go to the demo part. First of all, let's just go back to this build graph patterns. And this is the transaction. This is the amount pattern that we're looking at that I just described. There's the trust score, transaction as transact, and also payment, right? And if we click on this, you can see that there's the filter, and there's aggregation that we're using, referring to another vertex. So this is the alias concept. And we're also using the function aggregation sum. And we're creating another alias and attribute actually on the user. And then we're ordering this total amount on the user, right? In descending order. And we're getting the top 10. And the other vertex, if you look at this one, yeah, we have a filter here, trust score less than 0.1. And on this one is relatively easy. We don't have any filter or aggregation. But what we do here is, okay, there's a transact for the name. So this is the alias that's in the other vertices that you can actually refer to this vertex, right? Okay, so let's just run this pattern again. And of course, you can see that this orange glow here, all of them are in a transaction in the results. Let's run it again. Okay, that's very interesting, right? We find 10 clusters. Again, we're finding the top 10 people. So we find 10 clusters that with the output that we want to see. If you zoom in, right? Let me just control this a little bit. Let's zoom in. This is actually a super interesting cluster that somehow there's a two person that's connected with these two payment instruments, right? And now we're wondering, these people, the total amount, this user 27233 gets total amount of 2349. That's the dollar amount that they got. And then here, this total amount is 3804, and they are somewhat connected. So you might think that, okay, either they are in kind of a fraud group together, or maybe they are actually the same user, right? So they might be using the fake identities. So yeah, so with this pattern, you can probably find out more information, and you can definitely focus, have a laser focus on these users that you identified and just look into other histories. Okay, so this is the pattern, and let me just show quickly how to construct this. Let's let's do add a new graph pattern. And here, this is module 3 demo add. Okay, so what I want to use here is, again, using the pick tool. And let's use the pick tool. And first, get into the user to payment instrument. So this is one of the edge that I am interested. And then there's another one is user receive transaction. So I'm going to pick that edge too. And okay, now we have two of these together. So when you get these two patterns with the pick tool, now what you can do is actually using the merge tool. Let's see. You can do shift user and use the merge. Okay, now we have the the basic structure here, user to payment. Now let's just start working on the transaction node. As we were talking, that we are using a alias here. So I'm using the alias here and update. And now transaction vertex is saved as transact so that the user can refer to. The next part is the payment instrument. So what I can do here is, let's see, if you go back here, the user payment instrument, we want the trust score less than 0.1. So we're going to use a filter here. And when you're using filter here, there's different things that you can choose. Let's using expression 1 is smaller than expression 2. And we're looking at the trust score, which is the attribute for this payment instrument. Let's go to attribute and trust score. And expression 2, which is on the actual number. Let's give it a real number. I think we give it 0.1, right? Let's just check that again. Yes. Okay. Let's give the real number 0.1 and update. Okay, we have this filter made up, right? It's already here constructed. Now let's go to the user, which is the I think the most complicated one. And we have the trust score less than 0.15. Okay, let's do that. I'm already clicked on the user, do a filter again. And It's very similar to the previous one. Let's do a smaller one and attribute again, and the trust score and expression 2, also another real number, 0.15. So this is where you can actually, do something that number that you can change. And let's continue working on this. As we were talking about, we want the aggregation, looking at all the transaction amount, right? So we go to aggregation and add. And the function, we're using the function here and multiple functions here. And in this case, we're using sum and summing up the expression. Now this is where we are using the alias. We're using attribute of vertex and or edge instead of attribute of this particular user, right? So let's do this, and it will give us option transact because I already did the alias here. And let's do amount here. Okay, and I'm saving this as total amount. Update here. Okay, we actually have the aggregation here. And now let's remember that we actually want to order it, right? Getting the descending order. Let's go to the order and expression here. Now it actually, because total amount just get calculated, we can use the attribute here. And this total amount shows up. So, and then we want descending order so that when we use the limit, we can get high to low, right? So let's done, update. Okay, we have the total amount of descending order. Now let's go to limit. And we're using limit. And of course, you can choose the number here. And I'm just going to keep at 10 and update. Okay, we basically had this whole pattern ready. And now let's use this in result and make it into orange glow here. Everything is on orange glow. And this will be shown in the results. Let's remember to save the pattern here. And it actually clear out some of the reminder to make things into the orange glow, right? So now this is saved, and let's run the pattern again. Okay, now we're getting back to the same results as the one that I already prepared, right? So again, we see this interesting cluster connecting through two devices. So this is a very interesting pattern. Of course, you can modify as you like. And yeah, so this is the module 3 demo. And let's go back to the workshop guide. If you're looking at the workshop guide, this is a module 3 instruction and follow it through, right? So since this time we don't have to terminate and recreate solutions, I think 10 minutes is sufficient. Let's go back to here. We do have an optional graph pattern that you can work on, but maybe it's a little bit limited time. So it's up to you whether you want to work on this additional one pattern. And then the concept is very similar to what we've shown in module 2 and 3. And if you really have questions, you can, there's a documentation on the Visual Query Builder and could help you to identify how to do these different steps. Okay, let's give 10 minutes to this and come back at 10:55 a.m. PST. I think it's 1:55 p.m. ET, right? And you have the instruction link in the chat again. I might as well just paste that again. Okay, I'm going to paste that again. And happy Visual Query Builder.
So Emma, there is a question for you on automation of this process. I guess the question is how to parameterize these queries that we have written. Maybe you want to answer that.
Yeah, so for the Visual Query Builder, currently you need to go through the UI to construct it. However, like if you write a GSQL query, after you can definitely write it either in GraphStudio or in command line. And then with that, you can automate as much as you want. So you can use parameters and as well. So I didn't show the parameter feature here in Graph Pattern, but in module 4 and 5, you can actually get to that, how to use the parameters and parameterize for many of the user amount and all those things that you might consider it as a variable.
Right. So if you remember the first exercise, there was a user ID put in. I don't remember the number, some 2, 3, 4, 5, 6. And that ID can very well be parameterized through the Graph Visual Query Builder. And then you can fire that query for as many numbers of records you have and finding all the low trust score based transaction which takes place. It's just that hasn't been shown, but it is, as Emma was saying, it's the part of the next exercise. Yes, Parquet is supported data format. You can use our connectors via Spark connector, and that would support Parquet data format ingestion. Directly from GraphStudio is yet being built. It's on our roadmap. But if you need to read Parquet files, as I sent to one of another question and linked to our, there was a link to our GitHub library where we have all these connectors which are open sourced.
Yeah, I just want to add one more on that. Actually, if you have the Parquet in S3, it's already supported using the GraphStudio S3 import.
Oh, wonderful. Thanks. I learn new things every time too. Thank you, Emma. You want to take this question, which says build graph pattern also can, when are we supporting UDFs out of the graph patterns?
Yeah, currently we are not supporting UDF yet. So definitely in that case, like you want to use the GSQL query and, or just UDF directly, we can consider this to add to the roadmap. And of course, the Visual Query Builder is at the first version, and we will be iterating on top of it so that it make it more, include more functionalities in the future. So.
And Eric, to add to Emma's answer, yeah, please go ahead, Emma. Sorry.
Oh yeah, because there's a second part of the question. Convert legacy complex GSQL to build graph pattern UI. That is a slightly more complicated task to do. Currently, it's not on the roadmap. If you really have the need, we can discuss what part of that we can actually achieve.
Right. So, and Eric, to add to Emma's answer, don't see as Visual Query Builder as a replacement for GSQL query writing, because GSQL query writing can be extremely complex, very useful. There are graph algorithms behind it. Now, how are you going to replace the algorithm putting in the Visual Query Builder, right? It could be very challenging to do that. Now, why Visual Query Builder is that? For two kinds of users. The first are the business users who do not want to learn GSQL programming language and still want to achieve a lot. And secondly, for the set of developers and maybe not too much technical people on the product side, where they can get up to speed with the TigerGraph much more sooner and quickly. So it is not competing with each other. It's more like a complementary, depending on what user group you're referring to. For me, I'm a lightweight GSQL query writer. So for me, Visual Query Builder works very well. If there is a proof of point concept in my project, if we are creating an MVP, or we are trying to integrate with some UI. Emma, do you want to share some thoughts on that?
Yeah, I think you captured pretty well in the sense that theoretically GSQL is Turing complete. I have yet to see any of the visual UI based tool to achieve Turing complete. Theoretically, maybe it's actually not that doable in the reverse process. So definitely, if you have additional approaches to cover, have a UI way of doing Turing complete coding, definitely I would like to discuss with you in a intellectual conversation and meeting. Yeah, thank you, Eric, for all the interaction. It's actually a very interactive audience. It's been wonderful, actually leading this workshop live. We did this first time in Graph AI world, and we just decided to do it again because we got a lot of good feedback, and the interaction always is very fun, and you'll get each time you get new experiences, such as showing reset password. Yeah, I've seen that some of the attendees have shown definitely they've seen the patterns constructed and results showing up. Of course, if you actually have issues and troubles, don't hesitate to reach out to Abhi and me. And if you have issues with the TigerGraph Cloud solutions, you can definitely go to here. Let's see, there's a support button here, and you can select, have submit support ticket this way. So our cloud support team and operation team can take a look into your instance. For the query related issues, you can send the question to me and Abhi. Okay, let's just kind of wrap up in the remaining 5 minutes. We might be a little bit over it because I think Abhi has a demo that he wants to show. But what I want to
I think let's skip that for time being. I think we can wrap up well on time.
Okay, sure. That's fine. So I just want to quickly go over what's in module 4, which probably will answer some of the questions, for example, the parameters, right? So I don't think I will have time to actually go through the construction. But as you can see here, in this module 4, the steps are included in your workshop guide. You can actually use the widget tool here, which can, let's say, find the intersection of the result set of this user from left and user from the right. And you get to the intersection of this user, and then also looking at the additional conditions and patterns that are related to it. And the parameter here, for example, the max trust score and mean amount, these are both the parameters that you can leverage. If let's go to this pattern, low trust score, actually, I think it's a suspicious user, yes. If you use these follow instructions and get to this pattern, you can run and you will be able to see that, okay, I can actually put a real number of trust score of 1 and mean amount of 50, right? And then when you run it, run the pattern, this will show up. And then you run the pattern. And voila, you got the results out of here. And the output glow, we were only showing the user and the amount here. That's why you find these clusters of user and amount that satisfy that whole pattern, right? So yeah, this is a way to make it more universally applicable to other to the different parameters you want to input. And of course, you can save this as a GSQL query. And if you go to write queries, you can find the suspicious user, right? Okay, let's go to the slide again. We're not going to work on this in a workshop, but of course, after this ends, you can continue working on module 4. And module 5, it's actually a less complex feature, but mostly we're trying to get at is some of these features that you might want to use and leverage in your machine learning model, right? So these are some of the features that you can potentially plug into your machine learning training system that you're using. So again, it leverages the concept of parameter here and filter. So with follow the instruction in some of the previous steps and also the documentation, you should be able to finish this pattern as well. Okay, let's just jump back to the summary. So I think there's a lot of the product overview and differentiators. And I think you can look into our white paper and some of the other presentation in terms of how TigerGraph differentiate with all the other graph database and other analytics tools. So just a high-level workshop summary. What we did is we focused on one use case, which is the anti-fraud and anti-money laundering use case. This is used throughout all the modules, and hopefully you get a sense of how you can use graph analytics to do anti-money laundering and anti-fraud in your enterprise. And then we extensively used tgcloud.io, which is the database as service for TigerGraph. And you actually learn how to register and also start solutions and terminate solutions, and also access the database TigerGraph solution from there. Then, of course, we learned how to use the 3.0 features, no-code features, which is use the RDBMS to graph, which Abhi had a wonderful presentation on the exercises. And then I also showed a few of the modules that kind of introducing you to use the Visual Query Builder. Of course, there are a lot more to the Visual Query Builder, and encourage you to finish the exercises, as well as looking into some of the other documentation that we have. So just call to action, definitely use the cloud platform to finish the optional exercises. And the MySQL database connection should be up in the next week also. So you can probably still use the MySQL connection for your Module 1 exercise. If not, you can create your own MySQL Postgres and use the feature. And continue constructing new graph patterns in your own data set, right? And we also have a lot more starter kits in tgcloud.io. You can leverage that to experiment with Visual Query Builder in other data set. All right, with that, thank you all for attending this super interactive live workshop, and some more resources here, and we'll be sending out the recording and the slides and again the workshop guides in a follow-up email. Email me and Abhi if you have more questions regarding the feature enhancement and suggestions. Thank you.
Thank you, everybody.
Bye.
Bye-bye.